So today we are going to study the area of isosceles triangle. So in yesterday's problems, we were discussing the vertical angle of an isosceles triangle. So the vertical angle of an isosceles triangle, and as shown in this figure, here this side, suppose we name it as O, this point as A, this point as C. In the triangle OAC, OA is the radius of the circle and OC is also the radius of the same circle. This is an isosceles triangle, therefore, with an angle, vertical angle, clearly it is an acute angle. Whereas in this picture, let us name origin O, this point is same as A and let this point be B. Here again OA and OB are the radii of the same circular arc, so they are equal. So this is also an isosceles triangle, but here angle theta is 90 degree. Now the diagram below. In this diagram, suppose this is again the origin, this is same point A, but suppose this point is D. OA and OD are the radii of the same semicircle. So OA and OD are again equal. So this triangle is again an isosceles triangle, but the vertical angle we observe, it is an obtuse angle. So that's why I yesterday asked one of those problems, what can be the value of the vertical angle of an isosceles triangle? It can be acute, it can be 90 degree, or it can be obtuse. So next we take up the first case when angle theta is 90 degree. This is a right triangle. Obviously its area is half into in case theta is 90 degree, area of the triangle is equal to half into base into height, and that is equal to half r square. But how this formula can work? If we see half r square sine of 90 degree, sine of 90 degree, we know how much it is. How much is the sine 90 degree?
7.
So that is 1. So this is half r square into 1. So we get half r square. So that means this formula works for angle theta equal to 90 degree. But we will prove that this area triangle formula for isosceles triangle works for acute value of the angle theta as well as obtuse value of the angle theta. So in case angle theta is less than 90 degree, that means acute. So this is that picture in which the vertical angle theta is acute. So we do a construction, we just draw perpendicular. Suppose we, from the point C, we draw a perpendicular to the base OA. Now suppose this perpendicular has the length equal to h, means height of the triangle. We can say h divided by r in this triangle. Suppose this point is named as M. Then in triangle, in right triangle OMC, h by r is equal to sine theta. That implies that h is equal to r sine theta, and so the height of the triangle for the base OA, which is r, the height is r sine theta. So therefore, area is equal to half into base into the height. Okay, so that is given by half r square sine theta. Is it clear?
Sir, yes.
Can you take a snapshot, everyone, for this much part so that we can proceed for the last case for the obtuse angle? So everyone has taken the snapshot.
Sir, yes.
So I am erasing this part. Now we take up the last case for the obtuse angle. That means in case angle theta is greater than 90 degree. This is that picture in which angle theta, the vertical angle theta, is more than 90 degree. That means obtuse angle. Again here for the base OA, we want the altitude, height. Now the opposite vertex is D. Opposite to the base OA is the vertex D. And from if D we want perpendicular to OA, it cannot meet OA segment inside, but we will see a perpendicular from the point D will meet at the external point of OA. That means AO produced, suppose at the point N. So this site is H. So because it is an obtuse triangle, we will have to use the coordinates. So what is the x coordinate? We don't need because we need sine theta. So y coordinate is h because h is positive and the y coordinate is also positive. So y coordinate is h and radius of the circle is this r. So we have sine theta here is equal to h divided by r again because h is the y coordinate and r is the radius. So that gives us h is equal to r sine theta. So we have area is equal to half multiplied by r multiplied by h. That is half into base into height. So base is r and height is h, and h has the value r sine theta. So we have again half r square sine theta. Is it clear?
Sir, yes.
So you can again take a snapshot. Yes. So, Jasmeet, have you said something?
No.
Okay, so now we proceed further. I am stopping the sharing. I take up the next page. This is a problem I will share. It is a problem based on area of isosceles triangle. Is that visible?
Sir, yes.
So the problem is that, as seen in the figure, AOB is a diameter of a circle with center O. So AOB is a line passing through the center O of circle. So AOB is a diameter. If C be a point on the circle such that angle BOC is 60 degree as shown in the figure, find the area of the triangle AOC. So we have to find the area of the triangle AOC. Yes, yes, Jasmeet, you are saying something. So area of triangle AOC. AOC is an isosceles triangle because OA and OC are radii. Suppose that the radius is hers. Why is to suppose it is given in the problem? Radius is R. So OA and OC both are equal to the radius R. This is area of isosceles triangle. If we know this angle, then we have the formula half into R square into sine of the angle, the vertical angle. The vertical angle is angle AOC. This is equal to half R square sine of, because we see AOB is a diameter, and so this angle is 60 degree. This part is how much? This is how much angle it is?
120 degree.
So 120 degree this is. So here we have the use of the acute angle, sine of the, obtuse angle, sine of the obtuse angle, half R square. We know that sine of 120 degree can be written as sine of 180 degree minus 60 degree. So Saturday we did this thing, sine of 180 minus theta is just sine theta. So this is half R square into sine of 60 degree, and that is equal to sine 60 degree is root 3 by 2. So this is equal to root 3 upon 4 R square. Do you remember any formula like this? You have already done in the 10th class. This is a for a very specific kind of triangle, area of the triangle, this formula. Which kind of triangle?
Equilateral.
Equilateral triangle. So equilateral triangle, actually how equilateral triangle comes into play, see. If we join BC, then triangle OBC is also isosceles because this is OB is radius, OC is radius, isosceles. So in isosceles triangle, the base angles, so this 60 degree angle is the vertical angle, and these base angles are equal So suppose theta and theta. So 60 degree plus theta should be 180 degree by angle sum property. Yesterday we discussed the problems on this. One last problem was that ki an isosceles triangle with vertical angle 60 degree actually happens to be an equilateral triangle, because this gives 2 theta is equal to 180 degree minus 60 degree. So theta is equal to 120 degree divided by 2. That means 60 degree. So these angles are also equal to 60 degree. And if we find the area of the triangle OBC using the formula we have done today, that will be same this half r square sine of this vertical angle 60 degree. So which is same as root 3 by 4 r square, means the area of the triangle AOC. What we learn in this problem is that area of the triangle AOC is equal to area of triangle BOC. The reason is that sine of 120 degree is by virtue of this formula is equal to sine of 60 degree. They are the same. So because of that, area of triangle AOC is same as the area of triangle of BOC. And we find that BOC is in particular an equilateral triangle whose area by the basic formula of 10th class can also be written as root 3 by 4 times the side square, and each side is equal to radius. Okay, got it? Got my point?
Sir, yes.
So can I pause this screen, stop this screen, and then proceed further? Take snapshot. So can I stop it? I am stopping this. Next, I am going to do a very important property of triangles. I am opening the file, now sharing it. Is this visible?
Sir, yes.
Now, this is known as sine law. What we are going to discuss is sine law. If the sides of a triangle, actually this is written incorrect. The sides of a triangle are proportional to the sines of opposite angles. Means, for example, the side BC, the length of BC is proportional to the sine of the opposite angle. That means sine of A. Right? Similarly, the side CA is proportional to the sine of the opposite angle, that is B, sine of B. And the side AB, its opposite angle is angle C. So AB is proportional to sine of C. So you have read about the direct proportion in the earlier classes. The ratio of the proportional quantities is constant. That means BC, suppose BC has the length A, BC's length is named as A because this side is opposite the angle capital A. So small a is the length of side BC and BC is proportional to sine of A. So A divided by sine A is constant. Means this is the same as the side CA, which is which length is denoted by small b because this side is opposite the angle B. So small b divided by the sine of b, this ratio is same constant, and the side AB whose length is denoted by small c, as this is opposite the angle capital C. So the length small c divided by sine of c is also the same. These ratios are equal. And in fact, here is also written if A, B, C are the lengths of the sides BC, CA, and AB respectively, then A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to twice R. Constant is twice of R. What is R? R is the radius of the circumcircle of the triangle ABC. Here see, this circle, as shown in the figure, is passing through the vertices of the triangle ABC. The triangle ABC's vertices, ABC, the circle is passing through those points. So this circle is the circumcircle of the triangle. Suppose its center is here, suppose O. If we join OB, then it is a radius. Similarly, if we join OC, this is also a radius. So these are radii of the circle, but radius is given as capital R. Now from the properties of circle done in the 9th class, if this angle is capital A, what is the angle BOC? Who will tell? Yes, anyone? Amraj? What is angle BOC equal to? Anaj? Anmol? Nobody remembers? Mansirat? Pushpreet? Nobody? Gurman? Jashan? Jasmeet? Nobody is telling.
Sir, half of angle A.
Yes. Who is telling? Yes, again. Yes. Anyone? Anmol? Okay, my voice is coming.
Sir, yes.
Angle O is twice of angle A. It is twice of A. If I draw a perpendicular from O to BC, then it makes the chord BC half perpendicular drawn from the center of a circle on a chord of the circle. BC is also a chord. Bisects the chord. You remember this property also? Yes.
Sir, yes.
So this part is A by 2. this part is a by 2. And similarly, you know that this angle is equal to this angle because these two triangles are congruent. Yes.
Sir, yes.
Now what I found, if angle A, vertical angle of the triangle is A, then angle BOC is twice of A. Half of that is here, angle A, and half of that angle A is here. So angle, suppose this point is M, angle BOM is also equal to angle A. Is this much clear?
Sir, yes.
Now in triangle BOM, which is right triangle, BM divided by OB is how much? BM upon OB. This is equal to sine of angle A. See, for the angle A, BM is perpendicular and OB is hypotenuse, opposite 90 degrees. So perpendicular upon hypotenuse is sine of the angle A. Is this?
Sir, yes.
So that means that what is the length of BM? BM we have seen it is equal to A by 2. And what is OB? OB is the radius capital R. This is equal to sine A. Or you can say A upon twice R is equal to sine A. Interchanging the numerator of the right hand side with the denominator of the left hand side, we get A upon sine A is equal to twice R. Is this much understood?
Sir, yes.
So you can take the snapshot. Done it? Have you?
Sir, yes.
Okay. Now, in same way, we can find B upon sine B. If we construct this radius also, this we won't write, but we can understand that this is a similar procedure. This angle is B, therefore this angle is double of that, twice B. Again, if we draw the perpendicular from here on the chord AC, then this part is half of this chord. So this is B by 2, and this is the radius R. And because this angle is B, this total angle AOC is twice of B. Therefore, this part is B, this part is B. And again, from this, similarly, we get this ratio, B upon sine B is equal to twice of R. And lastly, in the third triangle, this very angle is twice of this angle, that is twice of C. And if we draw a perpendicular, from O on AB, then this part is C by 2, and this angle is, because this total angle is twice of C, and this is angle C, this is also angle C. From this way we get, from this triangle, small c upon sine of capital C also equal to twice r. So all these three quantities are equal to twice r. Is it understood?
Sir, yes.
So any other doubt? Anyone? Mansirat,
No, sir.
Pushpreet, Jasmeet, Jashanpreet,
No.
Gurman, Arpan,
Sir, no.
Anmol,
No, sir.
Anaj,
No, sir.
and Amraj. Okay, so you have taken snapshot, then I can close the class here today.
Sir, yes.
Sir, yes.
Okay then, right. I am stopping the sharing. I will be putting the video also in the class. Today I have tried to make a better one. So let us see how is it. Okay. Okay then.
Sir, yes.